Oh, yeah. I don't know. A lot of people, again, like more people I know have gotten in the last month than the entire rest of the medical stream. Let's see what's my thing.
I think everybody will experience like one way or another.
Yeah.
Like yeah, there's no escape. I feel that way because like I got it so recently and I was like literally very cautious about it.
Yeah, exactly.
But then like there's nothing much you can do about it.
Yeah.
Yeah.
I'm still trying to avoid, like, I don't go
Yeah,
to
you're-
my restaurants, but
you should,
yeah, but
I,
There's no way like you should still try.
yeah, for sure.
what were your symptoms like? Were you very affected, or
But
what were your symptoms like?
yeah, I had fever and headaches, like sinusite, like
Oh,
you
I
know,
see.
it was real bad.
Oh, I see.
I don't know. And then like muscle pains,
I see.
and fatigue.
I see, I
Like,
see.
the worst part was fatigue
Yeah,
because
yeah.
I wanted to just sleep all the
Yeah,
time.
yeah.
I couldn't do anything else. Yeah.
Yeah. Right.
But like after 2 or 3 days,
Uh-huh.
it wasn't that bad.
I see. Okay.
Like yeah.
Okay. That's
And,
good.
but like I guess like everybody's experience is different as
Yeah,
well.
yeah, exactly. Right.
Some people don't feel it at all.
Right.
I don't know.
Yeah.
Yeah.
Yeah. One of my colleagues, he got it from his mother in a nursing home. His mother's 90 something,
Wow.
and she didn't like feel anything at all.
Yeah,
You know, so
right?
yeah.
That's a miracle.
Yeah.
But that happens. I don't know the reason behind it. Like,
Yeah. Yeah. Okay, let's see. This is gonna work. Okay. So, I think next week maybe we'll be on Zoom. So, just to try to avoid, because I'm getting a little worried about cases and all that, and especially Daniel's thing saying that there are 3 people in his cohort who got COVID. So I'm concerned about not doing it in class. That's why I bring him our air filter and stuff. But anyway, so we'll be on Zoom next week. And in terms of the grade and stuff, I guess we haven't talked about it much, but you can write a paper or something, or I can also just give you some problems next week. So I'll release those. If you just do those, that would be sufficient. Okay. All right. So what am I going to do? Today is, so I think next week we'll do repeated games and stuff like that. That's a pretty common topic which we can talk about. It's pretty straightforward. But today we'll finally, I guess we'll kind of do more stuff, which is I'm milking this model of the quadratic loss thing. How many models have you done like that with? You have your own preference, plus you have some preference of the other, about being close to other people. So I think this is like the 3rd or 4th one. So I'm just totally milking that. So this is yet another kind of version of that. So this is a paper I gave at APSA meetings in Seattle. I'm trying to get this paper finished. And at that APSA meeting in Seattle, there were very, very few people. Even without COVID, there weren't that many people, but there was literally 0 people, like 1 person in the audience or something like that. And we had a UCLA reception, and like 4 people came to this room. Anyway, okay, so what I'm trying to get at in this paper is talking about concepts. So what is a concept? So this is, in some sense, I'm trying to talk about how we mentally organize the world. So I remember reading some book which said, like, if you had no concepts, no generality at all, then your life would be very difficult. Literally, every time you saw a chair, you would think, what the heck is that? Because it's not exactly identical to the chair you saw before. In other words, your ability to generalize and sort of ignore detail is very important. Otherwise, every single day would look a little different, right? So somehow you've got to know that, oh, that couch is red, but every other couch I've ever seen before is black or blue or whatever, but somehow that's still a couch. I can sit on it, as opposed to some crazy, strange object. So the idea here is, so say that what do concepts consist of? So like if I put up these objects here, some of them are chairs, although some of them aren't. So what is a concept? It's just a category of objects. It's a way of categorizing the world. In this case, the concepts here are chairs. But if you were to define chair, what do how would you define these things? So like if you look up chair in the dictionary, something like, something you sit on which has 4 legs in the back or something like that, right? But is this a chair, for example? This guy here. Maybe. It's something you sit on.
No.
It's not a chair.
It's not a chair. How about this?
No.
No, it's not a chair. I think it's closer to being a chair. Oh, how about this? This is a chair? Yeah, that's a chair. How about this? That's a chair. How about this?
Oh, I don't know.
What is that? That's something you take camping and you sit on it. The back.
Okay, but it doesn't have legs.
Yeah, it doesn't have legs, right? So so what about this? Is that a chair? It's, you hang it up on like your ceiling and sit in. You sit in it. That's what it is.
It was a cage.
No.
Like birds or something.
No, it's something you sit in.
Oh, it's a thing.
Yeah, it hangs from the wall. Hangs from the ceiling, right? Is that a chair? Maybe. How about that? Is that a chair?
Yes.
Yeah.
Yes, but it has, where are the legs? There's no 4 legs. It doesn't. You don't need. So if you define chair, let's see what's the definition. Let's see. Huh? Let's see definition. Okay. A separate seat for one person, typically with a back and 4 legs. So typically, I guess. That's a bit of a hedge. Okay.
A lot of those have separate seats for one.
Yeah. Okay.
So it's, if 2 people sit in it, it's not a.
I guess if it's 2 people sitting, that's not a chair.
Google.
Exactly. Anyhow, so the point is that all concepts you can define them, but they're also kind of still, everything has some fuzziness basically, right? At the same time, even though it has fuzziness, we still need these objects to operate in real life, to communicate and to think in our own minds. So it's a pretty, some people spend their entire careers understanding this concept. Like, why do we have this concept? Like, politically, it's very important for mobilization. Like, one of our colleagues, Jeff in Paris, has this thing about people of color identity. Is people of color a thing? Is that a category or not? Like, literally, no one said people. If you said people of color in 1960, people thought you were talking about African Americans. Period. Right. So now the whole idea of like people of color is kind of encompassing, Latinx people, Asians, whatever, is a kind of a post-2000 kind of thing. So where did that come from? Is it relevant? It's important, of course, right? To the extent that you can mobilize, gender categories are very fluid, as we can think about. So,
There's a long thing about like the perfect. Yeah, the same thing, right?
yeah,
You read that, right? You read that.
I think everyone's read it at some point. I don't remember.
Anyway, in the early parts of the book.
Right.
We'll get the perfect chair.
Exactly. Anyway, so all I'm going to say is that like concepts are interesting and important to think about. Like they can change, they're contingent, we can make them, we can create them, we can, modify them, etc. Okay, so they're essential for individual and social life. One very interesting result from psychology is that concepts are less about definitions and more about closeness to an exemplar or prototype. So you can look up, when people think about concepts, they don't actually apply a definition in their minds. Rather, they think, is this thing close to what I think a chair is? Okay? So that's kind of what we did already, like in this thing. Like these things are chairs because they're sort of close to or typically something, right? Okay, what they don't do is they go into a definition, look it up, and then check off the box of the definition. Yeah? It's kind of people have kind of an exemplar in their mind. So this is like a cetus, yeah? Whether something is a chair is less about the definition or more about whether it is close to or shares attributes with the exemplar. Okay, so this is just a fact about human cognition.
So that relates to the exemplar, basically?
I guess this is the example.
The ideal chair.
And everything is, things are more light chairs if they're closer to the exemplar. I guess that's the idea. No. So, okay. All right, it's kind of interesting. Again, there's a whole set of topics about this.
It's like which states are in the Midwest?
Exactly. The other thing is like, is a taco a sandwich? That kind of thing, right? Exactly. What's in the Midwest? Haven't you heard about this? There's like a whole online debate about this. Well, then how would you define a sandwich?
Is it round sandwich?
Yeah, wrap yeah, exactly.
Then I guess a taco.
So it's an open-faced sandwich, a sandwich example.
Yeah, it does
You
make
can
a
close
lot
it.
of
You don't have to. It's hard to hear.
You got which, are they called sandwiches? Literally saying these are not sandwiches. What if it's like gluten-free bread or something?
Exactly right. What if it's between crackers?
Doesn't matter what it is. It's not.
Like if you get a burger from In-N-Out between lettuce, is that a burger? For example.
If you like have like two salty crackers and put cheese between them, is that a sandwich?
That is, to me, that is definitely not a sandwich.
What?
But
Why?
exactly.
Bread? Or cheese?
Exactly right. Okay. So anyway, this is an example. So say you have a sparrow and ostrich. Are they both birds?
Yes.
Yeah, but why are they birds? Because they have certain attributes, like so sparrow's feathers, wings, beaks, can fly. Ostrich has all those things but cannot fly. So the idea is when we think about whether something's a bird or not, we would say an ostrich it definitely is a bird, right? But somehow it's less of a bird because it doesn't match in one important way, it doesn't match the exemplar. So it doesn't sort of fit in the stereotype. Okay, and that's because it doesn't fly. So we've actually done like social psychology experiments where they take people and say, classify this, and people take a little longer to classify an ostrich as a bird than like a sparrow, okay, because it's farther away from the exemplar. Okay, so the sparrow is an exemplar, but the ostrich isn't. Okay, so I think what we can try to answer with this model is why are concepts based on exemplars in which several aspects are correlated? So if you look at like the sparrow thing, the idea is that all these things make up a bird, and most birds typically have these things. In that sense, they're all correlated. Having wings is correlated with having feathers, which is correlated with having a beak, which is correlated with flying. Okay? There can be some cases which are not correlated, like this one, but overall they're correlated. Okay, so the typical examples of this is like gender roles, or gender categories. If I look at this person, I don't know anything about him. But if you just look at that, you think that person is male. Okay, why is that? Okay, well, I don't know. What do you think?
Wearing a suit.
Suit, the clothing, short hair, yeah. Even stuff like posture or something. Yeah, exactly. Haircut, clothes. Oh, your watch. Okay.
Oh yeah, these women don't watch.
No. Well, her big one. Anyway, shoes. Oh yeah, shoes. Anyway,
I never.
I'm not a big watcher.
Belts.
Socks. Oh yeah, I guess we're not seeing socks. Name. Oh yeah, I guess
Wait,
we.
is this the thing?
What do you mean?
Women don't wear socks, like,
No. But what I'm saying is that
right?
things are so yeah, exactly. Things are so gendered that things which don't have to be gendered are.
I think what you mean is that these aren't gendered things. They just represent what you're
Yeah, that's what I mean. Exactly. Right. Exactly. Vocal tone. If we had listened.
Really bad where
Huh?
shoes without socks.
Yeah. It doesn't make sense.
No?
I don't know.
Anyway, your mannerisms, all these things can make up maleness, right? But what's interesting to me is why are there so many of them? So that's the thing, kind of like why are there female or male socks? I remember talking to my parents and back in Korea back in the day. First of all, the typical shoes were rubber, and they were not left and right-handed. They were actually identical, and also men and women wore exactly the same thing. They were not gendered, really. At least among these rubber shoes they wore. And so a lot of things are gendered which don't have to be in some sense, right? Like belts, socks. Why is that? Because in some sense we're actually, creating even more correlation than there needs to be in some sense, right? Hats, many things, even things like razors. Like there's like you go to the store, there's like a woman's razor and a men's razor, and they're literally the same project, but the woman's one is like pink and you know, and also costs more usually. Okay. So why is that? And so these correlated aspects constitute the category of male. And this correlation seems to be so important to us that we actually create more aspects which are correlated. And even a single deviating aspect makes us scramble cognitively. So like, say you see this picture, you know, are you okay with this picture? Seems fine to you? A lot of people would say this and say, what's the deal with that guy holding the purse? So whose purse is that? Why are you making that assumption? Right? Okay, so yeah, most people would look at this and say, that guy is holding her purse, right? But like, if she was holding the purse, it was not like you'd be saying she's holding his purse, right? Because we have this correlation pretty strong in the mind. It's almost so strong we don't even think about it. See what I'm saying? Yeah, it's a strong correlation. Yeah. Okay, so yeah. All right. So one way to think about this is, why do we have so many correlated concepts? Why does a concept consist of so many correlated things, as opposed to just like two things? Okay, so many. Like, why not just use one or two aspects to signify maleness, even just like your watch or like your hair, and just everything else signals something else? Okay, it's kind of inefficient in some sense if you think it's about communication. Okay, so the answer is going to be this. Okay. In this paper, I'm arguing that the concept exemplars are based on many correlated attributes because of social coordination. That is, because society deems it important that we agree on a person's gender and costly if we disagree. So the idea is, we're like you and I are looking at a person. If you and I disagree about whether that person's male or female or some other gender, then somehow that creates a kind of confusion which we think is bad. Okay, it's very important that we all agree on how to create these categories. So that's a reason why you have several characteristics are all correlated. Okay, and the idea is that if I signal maleness, say by just my wristwatch or something like that, okay, then I might see the aspect, but I'm not sure if other people see the aspect. Okay, because maybe you're not seeing the wristwatch, whatever. Maybe you're not seeing the haircut. Okay? But if I observe you have several aspects of maleness, like your hair, vocal tone, name, clothes, whether you have a purse or not, etc., etc., etc. If I see them all, I know that at least you're probably at least seeing some of those things. See what I'm saying? So it sort of gives me more confidence that other people are seeing the same thing I do. So that's kind of the explanation of stereotypes I'm giving you. Okay. All right. So the idea is that having several correlated aspects define male better, it better generates common knowledge, right? Because if I see several aspects of you which indicate maleness, if I see them, I think, well, another person who sees them, they might not see all of them, but at least they will see some of them, so therefore I have greater confidence that you will see the same thing I am. Okay? Yeah.
I guess could it also be a big part of that also allows for more variation out?
Oh, that's interesting.
It feels like the first example was clear, but we still know he was male,
Right.
but just because of
Oh, I
one
see.
character is going to change.
Oh, that's interesting.
Because it seems like it's similar ideas, I guess.
Oh, right. The more concepts you have, the more variation you can play with a little bit. Oh, that's interesting.
So
Never thought about that.
coordination and variation.
Oh, that's interesting. It kind of provides a baseline from which you can vary.
Right.
Oh,
That's the ostrich example too, right? Just because it stops being,
Right.
bird-like,
Right.
it still has some characteristics that let us know.
Oh, that's interesting. I'm trying to think how that's going to mess up, if it messes up my explanation or
It's
not.
okay.
No, but you could say that, okay, say that I define maleness by somebody presents 10 characteristics and they have at least 6 of them which seem male, then I'll call that person male, right? So then that allows kind of creative variation, but I'm thinking, okay, there are 10 characteristics, at least, then I think some people will see some of those 10, and then of those 6, maybe that still kind of works.
Coordination, but maybe also a variation.
Yeah, that's interesting. Yeah. I mean, a lot.
That's to interrupt the model.
No, that's interesting. I never thought about it. A lot of people say that, for example, about ritual activity, there's a lot of repetition, like when you sing songs in church or something like that, or, just, you say the same thing over and over again, but that's way too boring to literally say it all the time. So there's some, repetition, like verses and, rhyming, but there's some variation in it. Just like, we have in holidays, you have the same basic elements, but you try to innovate something. Okay, anyway, how does my model work? So again, the greater the need for coordination, the more aspects need to be correlated. Okay, not just hair, but hair, shoes, etc. And hence the coarser the concept. So The example I like to give here is something like, say that you and I are just talking one-on-one about like, I don't know, some concept or just about ourselves or something. Typically it's a very nuanced conversation. I will say like, well, I kind of like movies, but some movies I don't like, and this kind of thing, and we can talk about, all these different things, different ways things interact with it. And if I just say if all I say to you is I like, action movies, period, I like Tom Cruise, period, without any kind of nuance, you think that's somehow like not intimate, right? It's sort of very coarse, like, oh, that person just couldn't. However, if I'm saying in a very large crowd, like typically think of like a large political speech, people do not say nuanced things. They sort of hit certain points and they hit them really strong and hit them over and over and over again. So like you think of like any politician, they will say, they'll have certain points, they'll repeat them over and over again, they'll draw in historical examples. But what they usually do not do is a lot of sarcasm, a lot of nuance, a lot of shading, a lot of qualifications. Okay, so there's kind of a different way of speech in a very large context versus a more intimate context. And in some sense, if you and I, two people were speaking just face to face, and one person spoke as if it were like at a political rally, that person would be seen as very, simplistic or coarse or something. Okay, so do people use much coarser categories? In some sense, use stereotypes, use these exemplars much more than in a two-person kind of conversation. And that's my arguments about coordination. And in a large group of people, it's more important that everyone thinks that everyone feels like the same thing. Whereas in a two-person thing, it's less of a big deal. Okay. So here's an example. So this is Bill Clinton. This is he was originally governor of Arkansas. So what surprised me when I was a governor of a small southern state is I was previously governor of a small southern state. When I became president, he was so far removed from the American people, it's hard for them to see you as a three-dimensional person. We're just used to being people and dealing with people, and it really surprised me how easily I could be turned into a two-dimensional cartoon instead of a three-dimensional human being. Okay? And you have to discipline yourself. So he's saying that once in a larger, governor of Arkansas, people just know you as a person, but as the United States, you can't do that anymore. You have to kind of have message discipline, and you kind of become a cartoon. Okay? And it's almost required of you in some sense. Okay. So an example. This is about Jim Farber is an early gay activist. So he's talking about why a lot of early gay activists are kind of skeptical that people are going to call themselves bisexual now. He's saying that back then, the focused ideology you needed to stoke a young movement isn't given defined distinctions. Like he's basically saying back then we could have called ourselves bisexual too, but it was more important to say we are gay. Okay, that does not make now we're all about fine distinctions, but at the point you couldn't make fine distinctions in the past because you had a message and you had a brand, you had to push that. That's kind of this idea. Right? So, so the idea is that the way we think about sexuality is different if it's just like, a two-person context, about a relationship context, but if it's a political mobilization context, it's different. The emphasis wasn't on encouraging people to discover their sexuality for personal fulfillment, but rather megaphoning a stark bulletin for public consumption to bolster the movement's profile and image. So the idea is that the categories used for like everyday life are different from the categories you might use for political action or mobilization. Okay, why is that? And the argument is that it has to do with coordination. When you're coordinating a big group of people, you need everyone to think about the same thing, but if it's just you and another person, the common knowledge is much less required. Okay, so the model is this. There are two doctors in a clinic. So this is going to be a model of how people see the world. Each patient comes in some attributes or symptoms. So it's like, two people in a clinic, this patient comes in, and they say, oh, I have a fever, I don't have a fever, I have, rash or not. So the intake nurse announces some of them, and each doctor does not hear a given symptom with probability E, the error rate. Okay. So after the announcement, each doctor chooses a treatment. Each doctor wants to choose a correct treatment, but also wants to choose a treatment close to the other doctor. So that's very similar. It's not just very similar, it's the same as everything we've done the last few times, just talking about so the other model is like a social coordinate, like conformity, like you want to be close to the other person's opinion, but you also want to be close to your own. Okay. And last time this was R, but now we're going to call it K. The importance of being close to the other doctor is K, just a number. Okay, so here's my example. Say there's two patient cases and one attribute, you either have a fever or no fever. And each case is equally likely. If the fever, the correct action is 100, and if there's no fever, the correct action is 0. Okay. All right. So let's see. Okay. Let's see. Let's model this now. Okay. I'm gonna How does this model look like? And this is super similar to everything we've done before. Okay, let's see. So, okay, so we have two doctors. Okay, each one is going to choose some number. So it's going to be like how many milligrams of Tylenol or something. Yeah, which is like a treatment. Okay, let's see. All right. Let's see. What are the states of the world? Okay, so we said that the person can come in with a fever or not. Okay, and also each person, the nurse announces it, and then each doctor can either hear it or not. So there's some possibility the message is not this. So what are the states of the world? So first one is fever or not. Right? And yeah. Yeah, exactly, right. Exactly. So it could be fever, and then this is, so we'll call that for fever both hearing, right? Okay. And then another one is fever. I hear, you don't, right? So these are all possibilities of it's a fever. Say, for the non-fever cell, say it's cool, something. Similarly. It's actually 8 states of the world. It's either be a fever or a cool head, and then each person each doctor be impure. Okay, let's see. What are the partitions going to be in this?
Each knows whether they heard it or not.
Right.
They don't know the other.
Yeah. So person one cannot tell the distinction between this, right? So they do this. Person one simply can't tell between these two. But if they've heard it, they can tell they know whether it's a fever or a cold, right? Okay, what about all these things? Can person one distinguish among these things? This is person one didn't hear the announcement. No, so if they don't hear anything, they know nothing. The only thing is that so this is person one's distinction. So what about person two's? Well, yeah, it's going to be like, these two are like, person two knows this, but they don't know whether one got it, but they don't. So this kind of looks like this, right? This computer. But then if they didn't hear it, they don't know whether it's in any of these states, right? So it kind of looks like this. That's a very precious. Okay, what about the prior on these things? Oh, we said fever and cool head is equally likely, right? So this thing is altogether a half, this is altogether a half. Remember the probability? A message is lost is that was the error each. Okay? So what's the probability this happens? So it's a half has to be right? Oh,
Sorry, what was the question?
sorry, the probability that this state, say this state. So this is probably there's a fever and both messages go through. There's no
So
loss.
that's 1 minus this.
Yeah. So it's a half because it's probably minus 1/2 1 minus e squared. Oh, I'll put it. 1/2. 1 minus e squared. How about this?
E.
Yeah, 1/2 e. How about this? Same thing there. And this is the probability of both are lost as well. How about this? Oh, this is both still yes.
That's all right. 1 minus.
Yeah, minus e squared. This is going to be 1. 1 half E times 1 half C. 1 half E times 1 half C. Okay. Let's see, have we specified players' actions, state of the world, partitions prior, so we've done 5 things. 1, 2, 3, 4, 5. We only need one more thing, which is not exactly right. So I think I'm going to say person 1's utility, the function of x minus 2 is going to be they want to be they want to be close to the correct treatment. And then minus, I think it was k, how far they were from the other person. And then, let's see. Here, correct treatment. Is, say, I don't know, you give 100 milligrams of Tylenol. So that's an all these cases. And here's the correct treatment. So I think now we're more or less pretty specified. We have them. Yeah, 1, 2, 3, 4, 5, 6, all 6. All right, now we can actually now solve finite equilibrium. This is very similar to everything we've done in the last few times. Okay, so what does the strategy look like for person 1? It's going to be a number here, and a bunch of numbers here, right? These numbers all have to be the same. So let's see. My strategy essentially is going to be 3 numbers, you're going to be 3 numbers, I'm going to do this whole thing. But I'm going to simplify it a little bit by saying, it turns out if you solve it, if you don't hear a message, what do you think you're going to do here? So you don't know anything. You think a fever is equally likely from having a cool forehead. If you have a fever, it's 100, cool forehead is 0. So, if you don't know anything, what are you going to do? Huh?
Like, do you see what the other doctor does?
Well, no, you don't. No, you don't know anything. You don't. Yeah, you don't know anything about the symptoms, and also you don't know what the other doctor is. This is also.
They can choose any treatment between 0 and 100.
Right.
That's the split difference.
Yeah, you probably just split the difference. And you can either take my word for it, or you can complete the whole thing. But it turns out,
You signed 15 earlier.
yeah, exactly right. Just say. My dad was in a prison camp in North Korea, and since he was educated, they said, "You're the doctor." They said, "These are 2 medicines. One is red, one is yellow." He said, "If somebody comes to the decision whether to give the red and loss of the yellow medicine, that's what it consists of."
Maybe we'll need the matrix.
Huh?
Maybe we'll need the matrix.
Well, yeah, so if you don't know anything, you put 15. So similarly, a person, you put 15 over there. Okay. All right, so let's put the other ones that are going to be they're not as obvious. So say that this is X1 fever, I'll call it X1 fever. And this is X1 when you don't have fever. Okay. This is simply X2, and if person 2 sees there's a fever. Okay. And remember, if you know the person has a fever and you know for sure the other person knows that too, what are you going to do? If you knew for sure there's no uncertainty at all.
100.
In 100, you just give them the right thing, like there's no reason not to, right?
Right.
That's the optimal prescription, and you know the other doctor sees that, so you're just going to do it. Similarly, if you know for sure the person has no fever, cool head, then you give them 0. But the issue is, when you see, you might say, so you see the person has a fever, but you're not 100% sure the doctor sees that. So you think, oh, the doctor might not see it, and in that case, the doctor might be the fit. Right? So if I'm thinking about this X1F, I'm thinking it could be the other person sees it and does the right thing, or they might not, in which other speaker. Okay. So let's try to calculate X1F. So if my expected utility, this is just given X1F. And of course, it depends on other things, but I'm just going to focus on this one. What's this going to be? It's going to be the choice of x and f depends on the prior of these things, right? The probability of this is what? This one, 1/2 of x squared. And what's my expected utility in this state? I just use this in here, right? Yeah, it's going to minus 100. That, right? Minus k times what? x1 f? Oh, this is x1 f, right? Minus, in this state, what are you doing? So, my expected utility, I'm averaging over these two things, right? It's the probability of this times this. So, it's the probability of this times my utility in this state, which is going to be depending on x1 f and x2 f. Right? So I think this is makes sense? Okay, and then there's the other state. This is the one where I know but you don't. Right? What's the probability that happens? We have e times 1 minus c. Okay, and then what's my utility there?
Minus x squared.
How?
1 minus x squared. Oh, no.
It's going to be
Oh, I see.
same as this, except so this element is the same, right? I know the person has a fever, so I'm going to I want the correct treatment, right? But in this state of the world, I'm doing an x and f, and you're doing what? So all it's different is the previous. Okay, that's it. Just by taking this and taking the derivative of this with respect to x, 1f, and setting it equals 0, I should find that too. All right, so we're going to do that. We can simplify a little bit by just I'll multiply everything by 2 and divide everything by 1 minus c because it's a quantum factor, right? So when you multiply, maximizing something at the same time is maximizing the constant time of the thing. Right, so we can just take this out. So this is going to be what? 1 minus e. Okay, and then this is just going to be pretty easy, right? So you don't do it. Just so can I simplify a little bit?
Cancel out minus e times.
Yeah.
x1f.
Exactly right.
Yeah.
Yeah, this can cancel out, right? This is 1 minus e times something, and this is e times something. So it ends up being just 1 times, so this is just going to be minus x1f minus the whole squared. Right? That plus e and the minus, that plus e and the minus cancel each other, right? Now I'll do this, I'll just multiply this thing, k cancel 1 minus e. X1f squared. And then minus k times e. Oh, is that right? Yeah. x1f minus 15. Is that right? Okay, so that right. All right, so now what do I need to find my optimal x and f? So take the oh yeah, exactly. Take the derivative, set it equals 0. One could do a lot worse than just taking the derivatives of things and setting it equals 0. So in this case, so the dx of 1f of that thing is going to be, well, this is just minus 2 times x1f minus 100. Okay, right? And this is going to be what? Minus a, right? Or minus b. So that's minus f. And then minus a, b. Minus 50. Okay, that's right.
Forgot to last one.
Oh, 2, right, thank you. Can I simplify a little bit? Can I just,
You just get those twos.
yeah. I'll get rid of the minus 2, so this becomes x1f minus 100 plus k times 1 minus e. They're all going to become sort of positive, right? Plus e times x1f minus 50. I think it's right. We just divided our last two.
Last part is
Huh?
gonna be k times e. K. Last part, right?
Oh, there's a K. Oh, I
Minus
forgot the K,
two.
right. Thank you. Yeah. Looks like there'll be some cancellation, right? This will kind of, there's a, let's see. So this is x1f, I'll just expand now. Plus k times 1 minus e x1f minus k1 minus e x2f plus k e x1f minus 53 e 0. Let's see. I think I have.
Minus k x one.
Yeah, it's the cancellation here, right? So there'll be x1f minus 100 plus k times x1f, because this is minus, this k minus e and this k, that's one. So that's just k minus f minus k minus e x2f minus 50 k e equals 0. That's right. Okay, let's see. So what am I supposed to solve for? Huh? I think x1, not exactly, right? So let me see. I'm going to put all the x1s on one side. x1f times 1 plus k. And everything else I'll put on the other side is going to be 100. Plus k times 1 minus e x2f plus 53. That's right, right? I just divide one this way. 1f equals okay. Now, how do I solve? So I solve for x1f. Now, what's the next thing to do? Same thing for x2f, right? What would I get if I do that? Something very similar, right? So I think I would get, I would get x2f would be, let me make sure this is, I didn't make a mistake. Let's see. Let's see. No, this is what we got. Okay. I got x2f is going to be the same thing, right? Which is 1 over 1 plus k, 100 plus k times 1 minus e. x1f, you just switches the x1 and x2. Okay, all right. Now what do we do? Just solve it. We can substitute. Do you want to do that? Okay, so we'll just put this into here, right? This means that x1f 1 over 1 plus k 100 k times 1 minus e x2f, which is this whole thing, right? Okay, that's that. Now we have this term. I think that's right. Yeah, okay. All right, so let's solve this. This is now just, we're in the math world, right? So, what do I want to do? maybe. I'll bring my 1 plus k over there, maybe. I don't know. So there's no fractions, I think. And I did all this. Maybe I can get some cancellations. Should we do a 1 plus k again? Because just that we get all the fractions. Should that okay with like 1 plus k squared plus 1 half is 100. 1 plus k. 100. Oh. Oh, no, I mean, is there a mistake? No, the 1 plus k hits this too, right? Sorry. We can multiply 1 plus k and then that's the whole thing, right? We won't, so this is where we go, 1 plus k hits this, 1 plus k goes away, but this is it, by the way. Is that right? I think we're okay. I think we're okay. Now let's see, what do I want to do? Just bring all my x1f's on one side, right, I think, yeah? I hope it simplifies. We'll see. I worked it out. Huh?
Last part must be 50k times, I guess.
Oh, E, right, I'm sorry, you were thinking. Yeah, I forgot. Thank you. Yeah, okay, thank you. All right, let's see. I'm going to bring this over here, which is minus k times 1 minus e. Well, it's actually k squared, 1 minus c squared, right? X1f. That's what that, if I multiply that through, that's what it comes. And everything else is on the right side. 100 k. 100 k minus e 50 k 50 k. And multiply this into here, right? Huh, hope this is going to be okay. Okay, let's see. Huh? Hope this is going to release down. I hope, maybe it will. Maybe it won't, I don't know. All right, we'll just leave this aside for a second. So this is going to, should I just expand the heck out of it and see what happens? It seems like there should be. Well, hold on, there's going to be a, this is a 50k times k times e here, right? There's going to be a cancellation here, right? So, well, let's just, so 100, we'll just, now we'll factor everything. Okay, this is going to be 100k minus 100k e plus 15k squared e, right? Minus 50k squared e squared, right? Plus 50k e plus 50k squared. I think that's right. Is that right? K squared e minus 50k. I think that's right. Hope this is going to work.
Nothing cancels out.
Nothing cancels out? Maybe we could factor stuff to make it easier. Nothing cancels out? Well, this becomes 100k squared e, right? So that simplifies these two things. Yeah,
Yes.
listen to this. And this simplifies with this. This is 100. So it's 100k. Oh, this is 200k, right?
Yeah.
Okay, minus 100k e. But that's minus 100k e, but so it's minus 50k. Okay, and then plus 50 squared.
So 100.
Oh, it's 100k squared. Thank you. And then this is the only thing they have left, right? Everything else we put together. Yeah? Minus 50 squared. Is that right? 100, 100k, 200k. Yeah, I think it's okay. Okay. Now let's see. Hope this is going to work. Can I factor or something maybe so I can make it life easier? I can factor the 50.
Yeah.
Yeah, let's do that. It's going to be 2 plus 4k minus ke plus 2k squared e minus 3 squared e. Right? Hope that there's going to be a factor I can factor out of that thing. I'm doing. Should I try reducing this now too? This might work. Let's see what happens here.
Yes.
Okay, we need more space now. This becomes what? X1f times 1 plus 2k plus k squared, right? Minus k squared plus 2k squared e, right? Minus k squared e squared. So this is, I'm doing a lot of math in my head. This is just this, right? This is, I'm multiplying by k squared inside 1 minus 2e plus 2 squared. Okay. X1f. These things go away. Right? 1 plus 2k plus 2k squared e minus 3 squared. Oh, maybe this, I see something. Oh, we're kind of maybe in good shape, a little bit. Okay, I'm beginning to see something, right? There's this looks like this, right? So that's good. Oh yeah, we're getting close. I'm excited now. I'm hoping that actually might work. Okay, so therefore, okay, let's see. X1f is going to be what? This whole thing divided by that whole thing. Oh, okay, there's a 50 on top here. I'll put the 50 on here. 2 plus 4k minus 8i 2k squared minus 4 squared squared. All this, the denominator is 1 plus 2k 2 plus 3 squared minus 4 squared. Okay, so it's going to be 50. This thing looks a lot like this, right? There's elements which is so. I'm just going to make something look like 1 plus 2 plus 2 squared. Okay. So. Okay, that's that. So I'm just making this because I want to take a 1 out. That's what I'm trying to do. Okay. And then, so I have to add this will cancel out this. Right? Is that right? You see what I'm doing? So this thing is equal to this. I think. Yeah? Is that right? Because I added this here.
But we already have like 2 plus 4K.
Oh, yeah, okay.
So we can write that and we have.
Oh, I see what you're saying. Yeah, I understand. Oh, I got you. Okay. Yeah, that's what you're saying. Okay. So, I'm just going to do that. Oh, then the KE. Is that what you're saying, or what? You would take, yeah, there should be some sort of cancellation, something.
Yeah.
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 Oh, I see.
You
Oh,
could just
you could have just written the.
write like 1 plus 2K.
I see, I got you.
Yeah.
1 plus 2K, right?
And minus.
Minus K. Right, that's what you said. Yeah, very good. Because that becomes a 2, that becomes a 4. Right, I see. Okay, so this becomes 50 times 1 plus 2K minus KE over this thing. Plus 1. Yay, that's good. And now I think I should be able to, I think I can actually do a little. Can I simplify more? Let's see what is my answer. What did I get here? Oh, okay, I think, all right. Huh?
They seem similar in
Yeah.
a way, but like.
Okay, let's see if I can, okay. Okay, so if I can factor, so I'm going to bring this one here. Maybe I can factor this. I'm going to say, let's, now how do I know this? Maybe that's the correct factorization. Let's see how that works. Okay, if I multiply this as 1 plus 2k minus ke, right, plus ke plus 2k squared e minus k squared e squared, right? That's it. If I multiply it out, this is what I get. Can you see? Is this the same thing as this? It's, oh,
First part is the same. 1 plus 2K.
so, oh, this is, you don't think it's, huh? Oh, that, no, yeah, I forgot, here's my 2K, I missed this, right?
Oh, no, this is.
Yeah, sorry. It works. I managed to factor this thing into this. Okay. All right. This is kind of like what you did last time. It must be. Okay. But this thing is equal to this. Yay! Boy, that's good. That works. I had a high school teacher. I was in a math team when I was in high school, where we actually went to math team competitions. That was my social life in high school. And she always said, it's really neat how math always just works. It never just doesn't not work. It just always works. It's just that's the way it is. What is this? This is 50 times 1 plus 1 over 1 plus 2. That's it. So this is not too bad. Sorry. Okay. Default solved it. Wasn't that bad?
Everything is relative.
Yeah, exactly. So this becomes.
Is what the final is going to be like, right? Yes.
You know, it's a hell of a lot. Think what people used to do in the old days. They would like learn Latin and stuff like that.
This is true.
Yeah. Learning something like not a big deal to do that.
This looks like logic.
All right. Okay. What is this going to be?
Same thing.
Same thing, right? Ends up being the same. Okay, what about this?
What is the K again?
Huh?
What does the K stand for?
The K is how much you care about the other person. It's like the R from last time. It's like how much conformity means to you. It sort of makes sense, like in a doctor's office, you don't want to do this different thing from the doctor's that would mess things up. Even if it's the wrong thing, there's something you gave to do the same thing as your couple. You don't want to like go into an operating room and the other doctor saying, oh, we're operating on the foot, where I'm saying, oh, we need to operate on the leg.
Even if you know they're sick.
Yeah, yeah.
An idea?
So even if you know for sure, in this model, even if you know for sure they need 100 milligrams of Tylenol, if you're not sure what the other doctor was doing, you might double check. All right, so how about here? So we do the math similarly, but can you, if I do it at home, see what you get. So let's think about this. Let's just interpret this. If K is 0, what is this number? If K is 0, right, this becomes 1 over 1, this is 2 to 100 exactly, right? So if you don't care about conformity at all, you just choose the right thing. Look at that goes. If E is 0, even if K is 5, what is this number? Also 100, right? So if there's, even if you conform, you want to conform to your friend, if you know there's absolutely no possibility of error, then you know they're all supposed to do the right thing. There's no disagreement between your friend, right? So it's also 100. What happens when K and E are both high? So K is 100, and E is like 21. Right? So there's a lot of conformity and there's a high probability of loss.
It is less than 100.
Okay, it'll become less than 100, right? And in fact, as K and E get larger, this number approaches what? 50, right? So if K and E are both large, it means that you're going to kind of shade to the middle, right? Because first of all, you don't know, you know that you should give the person 100 milligrams, right? But you don't know the other person knows that, your doctor knows that. If the other doctor knows that, they're going to get 50 for sure. And also, it's very, very important that you choose the same thing as the other person. So you're going to shake. So I think the analogous thing here, I think, is going to be 50 times, this is going to be minus this. Minus this. So there's this, if K is 0, this number becomes 0, right? Which is, in other words, if there's no conformity, you just pick the right. Okay, that's it. We solved it, more or less. There were some shortcuts we did, but it's something that you and I could do, in afternoons. Okay. All right, the end. That's it. Okay, so what's going on here? So what's interesting is, so let me go back to the thing. So let me see. In the manuscript version of the paper, let's see, where is it? Okay, this is my thing. I have lots of examples of this. This is kind of a fun one. This happens. So, this is the musician Laurie Anderson. Like, it's easy to get pigeonholed. Don't be caught in that trap of definition. I hate when people tell me what to do. So the branding thing is something to really avoid. Are you an electric acoustic avant-garde artist? Are you an avant-garde story artist? Who cares? I'm just trying to write some music. However, so it's about what bin they're trying to fill you in on. Every record has to be in the bin. I'm not saying that it's not important, but don't make it the first thing. So she says that it's very limiting to be put in a kind of bin, but still she understands why it's important. Okay. Right. So this is just a more general model of what we're doing, but okay. So this is what I have here. So in this case, there was just, instead of fever or cold, just one or two. There's two conditions you could have. This is just what we had over there, right? And so this is just what we just did. Okay. And I think in this one, it wasn't, the optimal choice wasn't 0 or 100, but I think it was 0 and 10 or something like that. So in this case, this is what I showed. So this is the equilibrium for this one. That's just this. Huh? Yeah. It should work. It's my law. I hope it works.
Well, we basically just double checked the case.
Yeah, exactly right, exactly.
What it was.
That's like my high school teacher said, you know, you could do it tomorrow, it'll still work the same way. That's nice. That's a nice feeling. Yeah, I like it, exactly. Okay, so these are the strategies. Okay. So I think in my little presentation, what did I do? So here, yeah, this is 0 and 100.
Yeah.
Okay, so
Why do we have
Uh-huh.
5 plus 1 over mod plus k? Like,
here?
normally we have.
Oh.
them in
Oh, no, I take it back.
parentheses.
You're right. It should be, I think it was between 0, you're right. It should be 5 plus 5 times 1 plus 1, right?
Yeah.
I'm sorry, you're right. I was wrong. What I specified before? Let me see. Oh, yeah, I'm sorry. Yeah, here, the optimal choice if it's between 6 and 4. Yeah, I take it back. It wasn't 0 and 10. So the 5 represents the median, the mean rather. Okay, yeah. Okay. So, yeah, yeah. So this number should be 6 when E and K are 0. And this number should be 4 when E and K are 0. Thanks. Yeah. Okay. All right, let's see. Okay, this is what I just did. Okay, so say that K equals 4 and equals 0.01. Okay, so then this is just, if you don't hear anything, you get 50, you prescribe 50. If you hear phi, you prescribe 98. That's just when I put E and K. So 50, so when, this is just, when you stick, K equals 4 and equals 0.01 here. That just number becomes 98. Okay. See a doctor. Okay, who's no fever prescribes 2. That's simply the 1 minus 1 over 1 plus Ke. Okay, so if you hear fever, you know it's unlikely it's relatively unlikely the other doctor hears nothing, that his message is lost, so you don't have to hedge too much. Okay, let's say that the E goes up to 0.1. This is a lot. So 10% of the time the message is lost. So now if you hear something, you hedge a lot because you're thinking, oh, the other person might not have heard it. The other doctor will prescribe 50, and I care about the other person does, so I'm going to hedge away from 100. Okay, similarly, I'll hedge away from 0. Why? Again, because if you think there's a probability that the other person is doing 50, you're going to move toward that person. Okay, so for general E and K, this is what we just did. Yeah, so we just verified. Okay, all right, so the higher E is, the higher K is, the more hedging toward 50. Okay, so that's a very solvable thing. Okay, so the next thing though is, say there's more than one attribute, okay, and so say in this case there's 3 attributes. So L lambda, so they're chosen to be sort of sound like the same. This corresponds to, like, I don't know. I gave it an interpretation here. I'm switching back. So itching and wheezing, so there's 4 possibilities. Here, itching and wheeziness are always correlated. You never itch and don't wheeze. Anytime you itch, you wheeze. Anytime you don't itch, you don't wheeze. But fever is not correlated. Okay. So 2 things are perfectly correlated. Okay, and say that there's 2 kinds of treatments you could do. So you can think of this as like allergy. This is like Benadryl. This is like Tylenol or something. Okay. All right. So now it's a little more complicated. So somebody comes in, they could have an allergy, a fever, maybe both, I don't know. Okay. So say that the nurse announces the first and third attributes, that is, itching or not or fever or not. The advantage of this is what? You get information on both possible conditions, right? The allergy or the fever, right? Okay. All right. So if there's a high error rate, then you get this situation. So if you hear itch, you'll prescribe 81. No itch, 19. If you hear fever, you get 81. So this just corresponds to the example we did before. That is, if you don't hear anything about, so if all you hear is fever, you don't hear anything about itching or not, you just give 50 right down the middle for Benadryl, and give 81 for the Okay. Anyway, so if you hear like allergy and fever, you do this. Does this make sense? This is just kind of like the two-dimensional version of this. Okay. Now, but the other possibility, though, so anyway, so when the nurse announces the first and third, the doctor's hedges before. But what if you're the nurse, you announce the first and second one instead? It's the same amount of information. You might say, why is the nurse doing this? Because you're just really announcing the same thing twice, because these are perfectly correlated attributes. Okay, because anytime a person itches, they also wheeze. So it's like saying itching and wheezing doesn't add any more information. Okay? However, what the difference is that if you announce itching and wheezing, then when the doctor hears it, he just say that he hears itch. Well, he knows then it's very likely the other doctor heard either itch or wheeze or one of those things. See what I'm saying? So instead of the error rate being 0.1, it actually kind of becomes 0.01. Yeah? Because there's two correlated things. It's much less. It's very unlikely that he will lose both of those things. Yeah? So essentially, the E becomes 0.01. So therefore, you hedge a lot less because you have much greater confidence the other person hears the same thing you do. Okay, so you hedge a lot less on the allergies, but the disadvantage is you don't treat the fever at all because you don't know anything about it. So you always give 50 for the second thing. Okay. All right, so when the nurse announces the first and second, okay, they hedge much less than the Benadryl. Okay. So you don't hedge as much on the Benadryl but you completely ignore the fever thing. Okay, so good comparison. When you announce the first and third, the uncorrelated attributes, you hedge on both things, but at the same time, at least you're trying to treat all diseases. Yeah? You treat all diseases, but you're doing worse at treating each one because it's hedging more. If you do the correlated things, then you hedge less on the one thing you're treating, but you're not even treating one at all. Okay, so categories are coarser here, right? Because you're kind of employing a stereotype. You only care about is two attributes which are correlated. Yeah, so there's no reason they should be, why you're not two correlated things? Because you're getting a kind of error correction in some sense. So here there's, all categories are finer, you're treating all things separately. Here they're coarser. Okay, so this is a thing. So you can actually calculate now the expected utility in all these things as a function of K and E. If K is 0, this is where you announce both the itching and the fever. That is, you treat both diseases. In K is 0, that's always valid, because there's no hedging. You're always giving people the optimal thing.
Is how many doctors
There's some?
No, K is how much drugs.
Yeah, K is something. Yeah. If K increases, however, so still for low E, this is better. You treat both diseases. But for high E, then it's actually possible that just treating one disease is better. Okay, because there's so much, because you're getting less hedging in this. As K increases, then the advantage of just treating one of the diseases increases. It's more possible. Okay, so that's the argument is, the question is why do you use a stereotype, why do you use an archetype? It's because in the presence of disconformity, the need to coordinate, and the presence of error possible in communication, right? It's actually better to use many correlated things than to use many uncorrelated things. Because uncorrelated ones is always better for communication directly, but it doesn't form common knowledge. That's the idea. And so if you just had one doctor, then this one too would always be there. So that's kind of the idea. So that's it basically. That's the explanation. And so the argument is that kind of like going to the Bill Clinton example, if you need large coordination, you have a very large audience, then you have to use coarser categories. Like you'd say, basically the coarsest category is like you're part of us or not, like in-group, out-group kind of stuff, right? Whereas if you're just talking to a friend, you don't have to say I'm gay. You could say, well, I like this, I like this. You don't have to say you're part of the category or something, right? But as for the purposes of political mobilization, you have to make a kind of clear distinction, right? Clear, coarse, and actually unreasonably coarse distinction, but that you need to do so, kind of employ a stereotype for the purposes of coordination. That's kind of the idea. So that's it, basically. Let me see if I can give lots of more pictures. So this is kind of the thing. I've got to figure out how to use less abstract examples. But this is basically R and rho and L lambda are basically the correlated things, and then the third one is not correlated. So in this case, if I just use the first and third attribute, so sort of the first and second one, I'm hedging less on this one I mentioned, but I don't try to fix this at all. These points are, by the way, the ideal treatments. If I do the uncorrelated 1, 1, and 3, then I can try to at least hit all the optimal treatments, but I'm hedging both in both dimensions. And so, that's the same picture I had before. So, ideas, yeah. So this is fun. This is when is K and E better? So this place it says in this great region when E and K are both large, then this categorization, in other words, you don't even treat the fever. These, in other words, it's almost as if you don't even see the fever, right? You don't even know. You're just treating the allergy. This is when you use a stereotype. When K and E are small, you can treat them. Another interpretation is, say that you and I share a specialized vocabulary. So, like when you say something, like say that we all play Dungeons and Dragons or something like that. So when you know, say, like I have a mage or something, I know exactly what that means, and you have like confidence. If we have a shared specialized vocabulary, there's less need for stereotypes, right? Because when I say something, I have a greater feeling that you will know it. But if we don't have a shared vocabulary, so in other words, it sort of reduces E in some sense. If we don't have a shared vocabulary, then we're more likely to use stereotype. That's an example. More examples. Simple things like this. This is another interesting one. Let's see. Say there's 4 possible cases. There's variation on one, variation on this axis. However, the dimension has 2 correlated attributes, whereas this one doesn't. This is not correlated. So sometimes, for line of K and E, the doctors will just treat this and they won't even think about this. What's interesting here is, if you're a patient here, you're really messed up, right? You're really hurt if you're never treated, essentially. You're always just given your service. So in this case, so there's kind of a contestation about which categories are being used. So certain categories can really be either good or detrimental to you. So that's not, so it kind of makes sense. Like, so that you might say, like, we're contesting categories of gender categories. If you don't fit into those categories, you're actually hurt by that, right? You can't be like given the right medical treatment or like treated the same right way or something. But that also might take away. You can see why people would be against that, because if they really invested a lot, it was really important to them to say they're on this axis, that they're treated best for their thing. Spending a little bit of those attributes for some other thing is going to hurt them. So in other words, this model also kind of captures the idea that people fight over categorizations, fight over stereotypes, fight over meanings. Anyway, that's it, basically. Same model. That's all just taking quadratic things, taking the derivatives that equal to 0. It's in the end, it's the same. So, anyway, that's what I'm trying to do with this. Another example, other things are like, in government propaganda, why is it always very coarse, basically? And the argument is because you pronounce it because you're trying to get everyone on board, right? You're trying to get lots and lots of people to be on board, and they're more likely to do it if they think that other people think the same thing. That's the idea. Anyway. So I'm trying to write this too. I'm trying to finish this paper. It's another thing I'm trying to do. Huh?
One paper at a time.
Yeah, exactly. Right, exactly. I don't know. What is that? Yeah. Okay, so I'm gonna say. Oh, so next time we're gonna. I think we should just meet on Zoom next time. Next week. I'm just trying to avoid the whole COVID thing, and we'll just meet twice. I guess we won't have a week left. I was thinking we could do a hike or something, just for fun. I don't know. Really? Are you into that? Do
Yeah.
you want to do it as a class time or?
Sure.
Okay. We could just have a chat. Don't need that. Okay.
Class life.
Should we meet around here, or should we could meet off campus, or I don't know.
I'm sure there are.
There's some spectacular ones not too far away.
There are. Tamara.
Yeah, exactly. Do you
Are
want
you concerned about going in the afternoon, though?
of traffic? When do we want to get back?
Or thinking Tuesday or Thursday for going to class?
I mean, I'm pretty flexible. I can do it on the weekend too, but I don't know.
Tuesday works better.
Tuesday? Do you want to just meet here? We could walk into Bel Air, but I don't know if that, does that count as a hike? I don't know if it's that spectacular.
There's one little place that's pretty close. I haven't been though.
Do we have cars? I have a car, but I
I
mean,
have a car. It's probably still a bit of a drive. It's like a 5-minute drive. There's there's a reservoir right there.
oh yeah,
It's called the Stone Canyon Reservoir.
okay.
There's a little thing there. And then Franklin Canyon is pretty close.
The one I like is Paseo, it's called Paseo Miramar. It's in the Palisades, it's about 20 minutes away, that's the thing. But maybe the closest, huh?
Say on Miramar trip.
Yeah,
Miramar? What's it called?
Paseo Miramar. It's kind of a long trail too. It would take 2 or 3 hours to go up and back. That's probably a little long, right?
30-minute drive.
Oh, okay. Let's just do something closer then.
He's right now.
Yeah, yeah.
Yeah. Franklin Canyons, there's a lot of stuff there, and that's 20 minutes away. And
If we just go north of campus, that's where the reservoir is? Or
yeah,
is
the
it-
closest thing is like, this reservoir. Surely there's hikes around it. I don't know.
Briarwood Park.
Just, I think whatever you're wearing is fine, yeah.
I've been to Getty View Park.
Huh?
It's right on the freeway on
Uh-huh.
the east side.
Oh, that's right. That's pretty nice,
But
yeah.
it's nice. It's nice.
That is really, you can actually see the 405 on it. Is that what you're talking about?
Yeah, you go, parts of it are a little close, but most of it's
Okay.
not that much of a problem.
Right.
It's a nice little trail.
Yeah. Okay, let's do that maybe. Okay, so should we meet here?
Yeah.
I mean, people think some people.
Yeah, yeah, okay. We'll meet here on Tuesday. Or do Tuesday or Thursday?
I would prefer Thursday if that works for anyone else.
Huh?
I don't think
It's Thursday.
Yeah. I don't know. I can do both.
Huh. Okay. Should we do Thursday or Tuesday? You could make Thursday though, right? You said?
I can't.
Maybe would it be better to do the number class time? Is that,
Oh, my mother's busy.
So she can come along?
Right?
You can meet your classroom. Thanks.
A lot here.
Yeah. Okay, so it sounds like, but Tuesday 2 people can't make it, right? Or we could do another day. I could do any time. Wednesday. When is your mother coming?
Wednesday.
Okay, I see.
she's here.
I have a little concert thing.
Oh, that's nice.
Like,
Oh, neat. I have a concert coming up too.
oh,
I
you play
play-
violin, right?
Yeah, I played my Santa Monica Symphony's playing on Sunday.
Oh,
I don't know what do you play?
I play cello.
Oh, cool.
I just got my bowl repaired today.
Oh, awesome, awesome.
Yeah.
You playing the symphony here?
Yeah.
That's neat.
You need to. You're
Exactly.
like a really good violinist, right?
Oh no, I'm not that good. No.
But Santa Monica Symphony.
It's okay. I'm the worst one. Like literally the worst one in them.
Is it community?
Yeah, yeah. It's a community orchestra. It's nice. I mean, if you want to play in a community orchestra.
Yeah. I will.
Okay, I'll send you.
Send me the deeds.
Okay. All right. So.
The cheerleaders?
Exactly. Okay. Yeah. Lynn Vavik plays viola. I've actually played quartets with her.
Oh, yeah. Lynn plays viola.
Yeah, yeah, she does. Yeah, yeah. yeah. And oh, we'll see. Okay. Okay.
Is viola like between
It is.
It's like slightly bigger.
Yeah. Almost everyone who plays viola has neck problems. Because
It's
kind of.
hard to
Yeah.
play.
Yeah, 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 yeah. Okay.
with the violin? Do you always have to play like this, or
Yeah.
is there another one too?
Not really.
It's hard. I guess it plays it somewhere else.
Yeah, it's not very ergonomic. It's like they didn't think about ergonomics in the 14th century. Whatever.
I think it's like the best way to like keep it very still.
Yeah.
Well, you have like a chin.
Yeah, yeah, yeah.
Yeah.
So, what are we thinking? Tuesday then? No, I can make Tuesday.
I don't want to be there.
I think it matches.
Okay. All right.
Let's do it.
Okay. Well. Okay.
Wait, sorry.
All right. Great. We could do Tuesday and Thursday. We could go. Okay. So let's meet. We'll meet here at this place, at Tuesday. It's class time. Does that make sense?
Should I drive or was the
I can drive.
So it's 5.
I think we just need 2.
There's the equal.
Igor Haas?
Yeah.
Okay, so I can drive when I need to.
Yeah. Okay. I'll pull the car in the you know, that little thing north of Bunch. You know, the
Because you, what, you can see 5, and 2 right?
I can see the total of 5, yeah,
Including,
including myself, yeah.
okay, I can drive.
Okay, cool.
I'll
So,
see if Leaport's playing.
so should we blow up the cars, or should we, like, we can walk to the, where would you park?
Is it?
Yeah, I'll park in the second and number
Okay, let's do that, yeah, yeah, okay. So, okay. But just send me then where, I guess you should
2.
tell
I
us
can
where.
park in 3.
Okay,
I
okay.
don't have a pass, so I just buy it.
Okay, okay. Oh, whatever. Then we could just meet here and then split up to the cars, and then go to just tell me where the we should.
Or I could just, okay.
Yeah, yeah. Okay, that's easiest. All right, that's fun. Okay, great. All right. See you next time too. Okay. See you. Exciting.